So let's try that again. Hello, everyone. Today I will be reviewing photosynthesis versus cellular respiration. As well, we will talking about energy. So you have seen the two words before, photosynthesis and respiration. This is not the first time, I'm sure. So here's just a few important reminders to compare them, okay? So remember, photosynthesis is associated to plants only. And they are the ones that basically use the energy of the sun. They take carbon dioxide from the air and water from the ground and produce glucose or sugar and oxygen that we breathe. Okay? So let's repeat that. Photosynthesis is strictly only for plants. And it happens in the chloroplasts of the cell, which is why it's only plants. It's not for humans. Right? Only plants. Respiration, on the other hand, like the word says it, cellular respiration, we use oxygen. Look on the left of the reaction. Oxygen is the oxygen is in the air that we breathe and the food that we eat, glucose. Together, they will give us carbon dioxide that we exhale and water that we either urinate or pee. Sorry, that's the same thing. Urinate or sweat, and energy for your cells to do your basic everyday functions. And those happen in the mitochondria. And the important thing to remember, respiration is not just for animals, but it is also for plants at night. That's why I wrote at night. Very, very important to remember. So plants do both. However, they'll do photosynthesis during the day because they need sun. That's easy. Where respiration is only at night, they do the reverse at night. So here's a few examples for the ones who do respiration. So animals, what we have, reptiles, mammals, sea animals, etc., and all plants. So remember, this is a super important reaction. Put a star next to it if you're writing this down, or if you're printing it, make sure you highlight that. And can I give you one piece of advice? Memorize one of the two, and you'll know that the other is the exact opposite. Like, for example, respiration is the one for humans. So we need glucose. Look here, glucose plus oxygen that we breathe. Think about it. What do we breathe? We breathe oxygen. We need food. We eat glucose. And that will give us carbon dioxide. We exhale carbon dioxide, water, and energy. And then you'll know that photosynthesis is the exact opposite. Look here, energy, carbon dioxide, water. Whereas in here, it was products. Now in the photosynthesis, they are reactants. So this is why plants and animals, these two reactions are opposite, but they need each other. Because now this carbon dioxide that was produced is now used in photosynthesis. And it's an ongoing cycle like that. So memorize one of these two and know that the other is the exact opposite. Okay? And may I also point out that they are balanced. 6 carbons, 6 carbons. 6 times 2, 12 oxygens. And over here I have, look, 6 times 2, 12. And here, 6 times 2, 12. Who can tell me how many hydrogens do I have in total? You can, oh, Kiros, hi. Long time no see. Happy New Year. So I actually forgot, hi. I forgot to mention, we have 6 times 2, 12 oxygens, plus another 6 here. So that's 12 plus 6, 18 oxygens. And the same thing here, 6 plus 12, 18. But who can tell me how many hydrogens do I have? Nathan Towers? How many hydrogens do I have? Any ideas? How about Marina? How many hydrogens do I have? Are you guys still there? Kiros,
Yeah.
what about you? Oh, okay. Tell me, how many hydrogens do I have? Who's answering now?
It's Nathan.
All right, so what do you think? How many hydrogens do I have in total?
To be honest, I have no idea.
Well, okay, how many do you see here in water? How many hydrogens in water?
2.
2 times 6?
12.
12. And here, look, it says 12.
Oh, yeah. Yeah.
So it is a balanced equation. Okay. So remember these two very well, except memorize one and the other is the opposite. And here's what I was telling you, cycle. The sun is the energy for the plant. It'll do photosynthesis thanks to that energy. It will create oxygen for us to breathe and glucose to eat. And there you see, it will give it to the bug or whichever animal, etc. And it will, then we start the respiration process. So respiration means the animal exhales CO2 and also gives out water for us to restart the whole thing all over again. So before I move on to the next topic, what type of energy is the sun? How do you call that? The source of energy? Is it wind energy? How do you call that? The energy from the sun. It has a specific name. You can write your answer in the chat. Kiros, would you know? What kind of energy is solar, is the energy from the sun? No idea? Okay, is it wind energy, solar, or electric? Which one would that be? Kiros. Yeah, very good. Solar. So here's the example. When you said solar, it is a renewable energy. So as you can see, it is constantly replenished and will never run out. Just give me 1 second. Yeah, so it will constantly be renewed and never run out. Let's hear Nathan. Can you give me an example of something that is renewable, another source of energy that's renewable? Something that never runs out. What do you think?
Solar energy.
Yeah, besides solar, we mentioned solar already. Something else. I don't hear you very well. Right?
Windmills, right?
Wind, very good. Yeah, excellent. Okay, so I'm gonna just adjusting something. 1 second.
Sorry, I was thinking of an answer.
No problem. Okay, so back to this. I was just adjusting something. My apologies. Okay. Yes, so wind is one of them. Very good. Geothermal. Marina, where is this from? Geothermal. You think that's in the air, in the water, or in the ground? Marina. Marina? Okay, so it would be geothermal. Coming from the ground, it is the ground, from lithosphere. And you have the non-renewable. The only two, put a star next to this if you're writing this down. The only two non-renewable sources are the fossil fuels and nuclear. That's it. Once you run out of that, that's it. There's no turning back. Whereas these ones, there's so much supply that we will never run out, thankfully. Okay, so let's look at more closely the different renewable and non-renewable energy sources, this time of the lithosphere. So this is energies that are coming directly from the ground only, okay? So here we go. For renewable, it's only underground. Renewable geothermal. So here, let's give you an idea of what it looks like if you've never seen that before. Renewable geothermal energy. You see, so that's a nice example here. You have energy that's emanating from the ground, warms up water above it, and it's the steam of the water that turns the turbine, which is really interesting. And it's a nice source of energy that is obviously will never run out of the heat of the earth. I mean, that's another. So you see, the ground heats up the water creates steam, and that moves the turbine. A bit like an old turbine engine from a train. And you have obviously the infamous fossil fuels. So more and more fossil fuels. Fossil fuels, let's write the examples. Actually, I should write them down. Fossil fuels, we have examples of natural oil or natural gas. There we go. We have coal. What else can we write? Another fossil fuel. Oil. Like engine oil, that sort of thing. There you go. And uranium or nuclear energy. Again, nuclear, it is from a natural source, uranium, but uranium is constantly disintegrating by nature and gives off a radiation. So we use that to, again, heat up water, and then the steam of that water will make a turbine spin and create electricity. It comes down to the same as geothermal. The only issue that uranium or nuclear power have very bad side effects if something were to go wrong. You can have radiation lingering for years in an area because of an explosion, a nuclear explosion. Like Chernobyl in Europe, there's still some places that detect radiation. And this is since over 30 years there, that there was an explosion and still feel radiation. All right, let's take a look at the hydrosphere. So these are sources that are in the water. Hydrosphere is in the water. So anything that is related to water, that's why I wrote hydroelectricity, waves, and tidal. High tide, low tide, high tide, low tide. So this movement going up and down, same with waves, again, activates a turbine. Because basically that's what you need. You need a turbine to spin. So if it spins, it will create electricity. Okay. And there are no non-renewable energies. Water is something that is constantly there. We can take a look at a tidal energy. Oh, there. So this is a before and after. Here. High tide is high over here. As it lowers, water goes in here and causes turbine to spin. So this constant up and down causes the turbine to spin, and then that will activate a motor, and then electricity will be created that way. I wonder if there's a quick video on that. Oh, there's it.
Renewable energy is energy that is replenished by nature so that it can be used over and over again. Tidal energy is produced by this.
I'll just turn off my microphone. Do you hear it well, Nathan?
Yeah, it was.
Was there an echo?
You'd have to play it again for me to tell you. Miss, there's no audio to it, by the way. Now there is, yeah.
Renewable energy is energy that is replenished by nature so that it can be used over and over again. Tidal energy is produced by the surge of ocean waters during the rise and fall of the tides. The world's oceans are extremely powerful, and the tides are no different. With tidal energy, we can harness some of this vast energy from the changing tides and tidal currents. The gravity between the moon, the earth, and the sun combine to move the tides in and out. The tides change at predictable times linked to the cycle of the moon. In some parts of the world, the speed and the difference in height of the tides is greater because of the local geography and the Earth's tilt. By placing devices that harness some of the tidal energy in these narrow channels, we can generate electricity that can power communities and contribute to the power requirements of towns and cities. With global warming becoming a greater concern, it is our job to find alternative ways to provide energy. ways that are more available and sustainable than fossil fuels. Tidal energy can play a big part in the solution, as it is renewable, predictable, and if combined with storage, highly flexible.
Thanks for telling me, Nathan.
No problem.
All right. So there's your tidal energy, the high tide, low tides. And the atmosphere. The only one for the atmosphere to remember is the wind energy. The only issue with wind energy, as powerful as it can be, is very costly. You need a lot of space for it. It can also damage habitats. It can hurt animals, like flying animals. So as much as it's got a lot of good, there's a lot of bad as well. That's really it for the atmosphere, the only one to remember. And of course, it is renewable. There are no non-renewable wind energies, thankfully. And the other is the solar. Solar is in the other, quote unquote, other category, because it's not in anything that is in the earth. The spheres I'm talking about, the atmosphere, the lithosphere and hydrosphere, they're all like the solid liquid gas sections of the world. But the solar is something on the outside. It's the universe. It's the sun. You can't say that it's the atmosphere. The atmosphere, I'd need to have like air involved, okay? And that's why wind is the only possible source for atmosphere. And for other, it's just solar. That's pretty much it. I'm gonna have you guys work on questions that I put together. Let me just stop the screen. You will find them. I'm gonna post them in a few minutes on Google Classroom, and it's everything we just did today. Okay. Give me 1 second. Any questions about today? I'm gonna stop recording.